Hi, so welcome. We're going to go through an introduction to Altair. You can follow along with this presentation, which is mapped to the notebook that we've given you. So hopefully this should be fairly easy to follow along. We've numbered all the examples in the presentation, so as I enter things, you'll be able to enter them in your own notebooks. And I would really encourage you to do that, to basically type whatever I type on the screen, enter that into your notebook, and keep track of what we're doing. I'll occasionally say, this is a good opportunity for you to pause the video and give this a try on your own. So I encourage you to give that a try as well. But again, the advantage of the video is you can pause, rewind, and so on to do some experiments on your own. So let's get going. How do we build a visualization in Altair? The first thing we're going to do is basically load all the packages that we need. So import pandas as PD. We're going to use pandas for some of this. Import Altair as alt. And then there's a little bit of this pretty printing stuff that we're going to use. So if you hit Shift Enter in your notebook, it might take a few seconds the first time you run it, but it will execute and hopefully everything will load correctly if you've installed all the packages we need. So these are the two things we're going to need to actually start to render things on the screen. Okay, now how do we get things to show up on the screen? As we mentioned before, Altair is something that is going to compile Python code into Vega Lite. So you're going to type code in Python, but internally what's going to happen is you're going to get some nice JSON, which is the format that Vega Lite understands and knows how to compile and render. So here's an example. We're going to just take in one variable. We're going to call it transmission. We're going to use car data. We haven't loaded the car data yet. You haven't seen the car data. All I'm telling you is there is a transmission variable. And so we can do something like this. Alt, which is Altair. Altair, encode the color using the transmission variable. Okay, and I'm going to say that the type of this variable is nominal. So if you recall, there's different kinds of variables that we use in visualization: nominal, ordinal, quantitative, and so on. So those are the ones that we're going to use. So in this case, we're telling it the transmission is nominal, and we hit Shift Run, and you will see the JSON. This is the JSON that Vega Lite understands. So again, all we're doing is we're saying we're going to encode. So we're using the color variable, okay, and it's going to take in transmission and map transmission through color, and we're also hinting to Vega Lite. We're telling it that the type of this variable is nominal, and alt, again, is Altair. So we're asking Altair to do this for us. So this is how we get color. The next thing we might want to do is actually encode something on one of the axes. So let's say we're going to build a plot. So we can do something like alt x. So Altair, using the x variable that is on the x-axis, encode miles per gallon for me. Again, you don't know that there's miles per gallon, but this is a variable that we have in our data set. So when you run this, you get, again, a JSON object that Vega Lite understands and knows how to render on the screen. It basically says, this is the instructions for how to render the x-axis using the miles per gallon variable. Okay, this is all nice and good, but let's actually do something with real data so you can see this work. Okay, so I'm going to load in a database. This is a cars database, one that you've probably seen in a bunch of different classes. It's located on some server that I have running on GitHub, so you can load it yourself. So we're going to load it, and then I will do mtcars sample 5, just so you can see what it looks like inside. So we're going to grab it, and you can see everything that's inside this database. So you can see that there's a model number. Let me get this. So there's a model number. That's a name. Okay, we have miles per gallon, which is a numerical value, quantitative. We have cylinders, displacement, horsepower, rear axle ratio, weight, and then a bunch of other variables. I don't remember what all these. Transmission is a Boolean variable. It's either automatic or manual, so that's either 0 or 1. We're just going to leave this for now. We could encode it as like a text string if we wanted to, but we're going to leave it for now. Okay, let's do something with this database that we've loaded. So now we're going to make a chart. So Altair, just like all grammar of graphics implementations, needs a few different things. The first thing we need to do is tell it what data we want. So Altair, make me a chart using the mtcars dataset. Okay, that's the one we just showed a second ago. And please make a point for every row in the database. So Altair, make me a chart. For every row, make a point. And voila, we have a single point, or what looks like a single point, rendered on the screen. Okay. What is actually going on is we've rendered a bunch of points, but they're all sitting one on top of the other. So we have a point for every car, and one is rendered on top of the other because we haven't specified that we want it encoded in a certain way. Like we haven't told it where to place the points, how to color them, and so on. So this is not a very useful implementation, but this is your first Altair chart. This is the little rendering of it, and next to it you can see this little 3 dots. If you click on them, it doesn't show up in this view because it's too small, but basically gives you access to a bunch of different things like being able to save the SVG and load the compiled Vega and so on. But we're not going to do that yet. I'll show you how to get access to that in a little bit. But you have that little ... which you can configure. And again, we'll talk about that later. But this tells you that Vega Lite did something. You have a little dot. So we have something, and it's not very interesting. So we're going to go on. Just in case you're curious, internally, okay, this is our little pretty print thing. This entire command, which let's just this bit over here. Okay, if I render this is the point that I just showed you. So Shift Enter, you can see the point. If we want to see what it looks like inside, I can ask it to make it into a JSON file, and this is a really ugly version. So we have this nice pretty print command, and I will execute it like this. Okay, and we will run. And you can see sort of the nicer version of this. This has all the data embedded inside of the JSON object, and then at the end you'll see a bunch of rules. In this case, there aren't any real rules, but it just says make me a point for every object for every row in this database. Okay, now we're going to move on to something a little bit more interesting. We're going to actually make a scatter plot. So instead of all the points sitting one on top of the other, we need to make a scatter plot. And if you remember your grammar of graphics, we need to do 3 different things. One is decide how we want to encode every mark. In this case, we're going to keep using a point. Then we're going to decide what data we want to use. So in this case, we're going to use miles per gallon, and we're going to indicate that it's a quantitative variable. We're only going to use one variable here. So it's going to be a very 1D scatter plot, but we're going to encode it along the x-axis. Okay, so that's how we're going to start. So in English, what we're asking Altair to do is draw me a one-dimensional scatter plot with a point for every car where the miles per gallon of the car determine the placement of the code. Okay, so we're going to translate this using the grammar of graphics. So we're going to say, hey, Altair, make me a chart using the empty cars data set and make a point for every car. And then encode. Okay, so this is going to be where we define the way we want to encode. We're going to say using the x-axis, encode the variable miles per gallon, and I'm going to tell you that the type is quantitative. Okay. Now when we run this, we get a much nicer scatter plot, which is automatically constructed. It knows the limits, the most and the least. It predefines those, creates those, it labels the axes for you. So this is the grammar of graphics at work, where basically you're defining a very limited set of things that you need to do, and Altair, or Vega Lite in this case, is taking care of the rest and figuring out how to plot it for you. Okay, so we have our nice little visualization. So again, Altair, make me a chart using the empty cars database. Make a point for every car, and then encode the miles per gallon variable along the x-axis. Okay, so those are all the things that we need to define when we're using the grammar of graphics. Okay, there are shortcuts that we can use to do this. So one, instead of typing all the stuff that we typed before, we can say empty cars, mark point, hey Altair, make me a chart using points. Alt-X, again, encoding using the x-axis, the miles per gallon. And instead of typing the type of the variable, blah, 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 we can actually embed that inside of here. So we can say miles per gallon is a quantitative variable. So that's what this little bit of code here does, is it indicates to Altair that this is a quantitative variable. Now we could also use nominal or ordinal if that was the case, but we're going to specify that it's a quantitative variable. So we run it and we get the same display. Now, Altair will do the best it can to actually infer the types of variables. So it happens to know that miles per gallon is quantitative when it looks at the data inside of the Pandas data frame or the spreadsheet or the database that you load up. It looks at miles per gallon and it then knows that it's a numerical value. Like all the values for miles per gallon are just numbers. So we'll make the assumption that it's quantitative. So you can actually just skip this part and just do Alt-X, just miles per gallon, and it will actually do the right thing in this case. There will be occasions when it won't be able to make the inference or it won't make the right inference, and so you're going to want to override it with something like this. So Altair is actually quite flexible in how it lets you describe certain things like encodings. So these are 3 examples that will actually all do the same thing. So you can see Alt X, make me an Altair X encoding variable and set it and use miles per gallon to do that. You can also do this, just X equals or color equals, as we'll see later, or Y equals, and it should do the right thing. There will be situations where you will prefer to use this kind of format versus this one, but this is, a shorthand way of describing what you want, and in some cases it will do exactly what you need, and so you'll be happy and that will be fine. Okay, so we saw an example of how to do a simple 1D scatter plot. Let's try a 2-dimensional scatter plot. This is an opportunity. You might want to stop the video and see if you can do this yourself. Try to visualize miles per gallon on one axis, let's say the x-axis, and weight on the y-axis. See if you can do that using the code that we just demonstrated, if you can extend it to make it work. All right, so we're going to build this visualization. We're going to say, hey, Altair, make me a chart using the mtcars dataset. Use mark point. So again, we're going to use points. We're going to encode. And here we're going to specify 2 different variables. We're going to specify miles per gallon, and we're also going to specify weight, because those were the 2 things that we wanted to put on the screen. The miles per gallon we're going to encode on the x-axis, so we're going to do it like this, and just put a comma, and then we're going to say y equals weight. Okay, so x will be encoded, the miles per gallon will be encoded on the x-axis, weight will be encoded on the y-axis, and we get a nice scatter plot. So before I move on, I just wanted to explain one thing about debugging Altair and Vega Lite. When you do certain kinds of things, like if you type the wrong variable name, then Python will give you a nice error message and it will tell you hopefully what's going on. Occasionally, though, you'll want to inspect the guts of Altair. And so one way of doing that is you can open this in the Vega editor. So maybe even if you don't see any points showing up on the screen, it's just a blank visualization. You can click Open in Vega editor, and it will go over to an editor on the Vega website, and will actually show all the code in this nice little editor. It will show you what it thinks the data is, how it's rendering different kinds of things. It will show you if there are any error messages, like in the logs. And so occasionally, if you get stuck and Python is not being helpful, you might want to try this to go and look to see what's going on. And you can go back here. You can actually modify this if you want directly and see what it would look like. So if you weren't happy with here, you can modify weight and try whatever you want, and it will render correctly. Okay, let's see if we can do something a little bit more sophisticated. So we had our very simple scatter plot. Let's see if we can build up on this. So you might want to stop here and give this a try before I actually show you how to do this. But let's say we have 3 variables that we want to encode. Let's say we want to encode miles per gallon on the x-axis, weight on the y-axis, and we're going to encode transmission, which again is either manual or automatic for the car. Let's use color for that. So give that a try. See if you can build that using just basic Altair code. Okay, so let me walk you through this example. So we're going to say, hey, Altair, make me a chart using the mtcars dataset. Use a point for every car, and encode these, please, using 3 variables. Okay, so we're going to use miles per gallon, we're going to use weight, and we're going to use transmission. So miles per gallon, as I said, I want to put on the x-axis, so x is miles per gallon, y will be weight, and color will be transmission. Okay, so oops, we forgot a comma, run that. And now we have a nice visualization with miles per gallon on the x-axis, the weight on the y-axis, and a bunch of points encoded using either this very light blue, which is for 0, or this very dark blue, which is for 1, which is not exactly what we wanted. So this is the first example of where Altair is making a mistake based on its wrong inference of what we wanted and what was the data that was available to it. So it looked at the transmission column, and if you remember, the transmission column was either a bunch of zeros or ones. So it made the assumption that everything between 0 and 1 was also possible, and therefore it should use a quantitative variable to encode this. And so it picked the spectrum of colors from 0 to 1, but we only have 2 colors, and we actually want to make sure that we're using the right kinds of colors to make sure that it's visible, because the colors need to be orthogonal, so they need to be very distinct rather than light blue versus dark blue. So let's copy this code, and we're going to move it to the next cell, and I'll show you a very quick fix to this. The very quick fix is basically to override whatever Altair is guessing the type of this variable is. So instead of letting it go on with its assumption that it's a quantitative variable, we're going to override it. We're going to say, hey, you're a nominal variable. And run this, and now we get 2 very nice colors, this orange and the blue for transmission. Okay. So this is okay. This is a perfectly reasonable visualization. The default for Altair, and whatever you don't specify goes to the default. The default for Altair in this case is that points should have no filling. Okay, so they're basically this kind of donut shape. This doesn't really look that great. It would be nicer if we could fill the points. And so Altair offers a way of accessing the defaults and overriding them for the entire visualization. So I'm going to paste this in over here again. We're going to fix this again, make it nominal. And then we're going to specify that the point, a property of the point, is that it should be filled. Okay, so we add this extra little rule, and there are other rules that you can manipulate, like the size of it, the stroke, and so on, that will basically override everything else. Okay, so we run this, and now we have a bunch of nice little points that are filled in either orange or blue. And if you look, you're already starting to sense some patterns in the data. Okay, the orange points are mostly to the bottom right, and the blue points are mostly to the upper left, and we'll talk about what those cars actually are later on. So life isn't entirely based on scatter plots. So let's talk about some of the other kinds of encodings that are supported with Altair. I'm going to start with a bar chart. And so we're going to, instead of using the mark point, we're going to use another kind of mark to display something on the screen. So here we're going to say, hey, Altair, make me a chart using the mtcars dataset. And instead of a point, please use a bar this time. And encode 2 variables for me. The variables that I want you to encode are the model, okay, the name of the car, and how much miles per gallon it gets. So I want at the end of visualization where for every car there's a bar that tells me sort of how many miles per gallon. So X, we're going to use the X variable for model, and we're going to use Y for miles per gallon, and we're going to render it. So that's not bad. We have a bar chart. We have a bar for every car. And you can see the model number down, or the model name down at the bottom, and you can see the miles per gallon displayed as the length of the bar. The height, the y-axis, is showing the miles per gallon. So we didn't need to actually indicate that it was a height or anything else. Altair knows that when you have a bar, when you say y, miles per gallon, what you mean is make the length of the bar proportional to the miles per gallon. And when you say x should be the model, it knows that model is a nominal variable. There is a set of distinct names, and you want on the x-axis a spot, a different spot, equal distance for every model that you have. So unfortunately, this is a little bit hard to read. So what I'm going to do is I'm going to copy this code and go to the next cell. I'm going to rotate the chart. And the awesome thing about Altair is all you need to do is switch X for Y and Y for X. And now it's a little bit more readable. So on the slide, it gets cut off at the bottom, but on your display, you should be able to read it much more easily. Okay, so that was nice. Can we actually do some computation on the data before we display it on the screen? So let's say we want to bin by the transmission type. So we want to know how many cars are there of different kinds of transmission. So we have to do this in one of 2 ways. The first way is the pandas way, which is maybe familiar to some of you who have taken classes where you used pandas, so you'll recognize the commands. And then I'll show you maybe a slightly easier way that you can do this directly in Altair. So to do this in pandas, we need to create a new data frame that will have the bin data that we want. So we're going to take the mtcars data set. We're going to group by the transmission. Okay, whoops, group by. And we're going to grab the count. So if I do this, you'll see a nice little display. Transmission is either 0 or 1, the manual or automatic, and you can see the number of elements, basically, 19 and 3. Now, we don't actually want the transmission to be an index, so we will do this, reset index. Okay, and we actually only care about the transmission and the model. Okay, in this case, we don't want this duplication of the same value across. So we're going to sub-select the two columns that we care about, transmission and model. And if we display this, we can see that we have the two columns that we care about. So we're going to keep this around in a new data frame called bind. Okay. We're going to rename this column just so it's a little bit easier to read. So bind, rename, let's make columns. We're going to make model. We're going to replace that by what it actually is, which is the count. So model now becomes count. Okay, and let's see what this looks like inside. Okay, perfect. So now we have a transmission column, it's either 0 or 1, and a count column, which is 19 and 13 in this case. For transmission 0, there's 19 of those cars. Transmission 1, there's 13 of those cars. Now you can basically do all of this in one command if you're sort of proficient, but I've tried to break it apart so you can see this a little bit in more detail to see how it's actually constructed. Okay, so we have this new data frame called bind, which now we can plot. So we have the data that we need. Again, what we want to do is plot based on transmission, either 0 or 1, the count. So we want just a basic bar chart with 2 bars. One should be set to 19 and the other should be set to 13. Okay, so how do we do this? We say, hey, Altair, make me a chart using the bind data set in this case. So we have this bind data frame. Make me a bar chart and then encode the values that I need. So encode the 2 values that I care about. Remember, the 2 that we've defined are transmission and count. We need to tell Altair that transmission is a nominal variable because it forgets and it'll think it's quantitative again. And we will put this on the x-axis, and then the count will go on the y-axis. And voila. So we have a nice bar chart with the 2 transmission types, 0 and 1, and the values of 19 and 13 as we've calculated before. Okay, so that was a little bit of a hassle. We did this using pandas. It turns out that this is a very common thing that we want to do in Altair. And so Altair has a bunch of functions that will make this easy. I'm going to show you a concise, easy way of doing it this time. There are more sophisticated versions of these transformations that we'll cover kind of in the next 2 labs. So the labs that are coming after this, you'll see many more examples of much more sophisticated transformation. And we'll also discuss the reasons why you might choose to do things in pandas or choose to do things in Altair. I just wanted to give you a sense that you should be able to do this in Altair very easily. Okay, so how do we do this? So we say, hey, Altair, make me a chart. Go back, use the standard MT cars database. We're going to use the bar again. We're going to make a bar chart. We're going to encode. Okay, and now we're going to say, please use the transmission and count. Now, count isn't defined yet, but I'll explain how that works in a second. So we're going to say, hey, Altair, on the x-axis, make the transmission. Don't forget that this is nominal. And then we're going to add an argument, which is bin equals true. Bin equals true says take all the different transmission types and put one transmission type, the 0, into one bucket and put the other transmission type 1 into another bucket. And then count is basically a magical argument. So it's a function. Notice I added these parentheses. It's a function that will count the number of cars, the number of elements, the number of rows that have been sucked into each of those 2 bins. Okay, so now y equals Altair, make me a y encoding and count. So notice I'm saying this is a Altair function or a Vega Lite function. So I've put the quotes around it because it is passed as an argument to Altair and then to Vega Lite. This is not a Python command. If I didn't have these, Python would try to run count as if it was a function and it wouldn't exist. And so that would not be the right thing. So we want to pass this. And so we're going to say it like this. Okay. Run it. Oops, forgot a comma. Run it. And we have our data set. Okay, before I move on, I'm just going to copy this because we're going to use this example in the next slide. So feel free to copy here. And I will show you what's really cool about these kinds of functions where you can do count. There are other functions that are built in that will support other kinds of calculations. So an example would be, I copied this over. Let's say I want to know what the maximum horsepower you can get for each transmission type. So how would I do that? Just like we have a variable called, a function called count, we have a function called max. So this will calculate the maximum of something that you feed into it. Now, what should we feed into it? For every bin, we're going to have a bunch of cars. We want to find the maximum horsepower. And so we will define it like this. So we will basically say, hey, Altair, bin this data for me. Take the transmission. Some of the cars are transmission 0, put them in one pile. Some cars in transmission 1, put them in another car. For each of those piles, for each of those bins, look at the maximum horsepower value for each of the bins, and then use that to encode along the y-axis. And so we have this display, so you can see the maximum horsepower available based on different transmission types. Now, in the same way that we did this, we can also generate simple things like statistical charts such as histograms. So let's say we want to have a histogram based on some quantitative variable. Let's say we want to do it based on weight. We want to know the distribution of weight of all the cars in our data set. So we can do it like this. Hey Altair, make me a visualization using empty cars. We're going to use a bar chart here, mark bar. We're going to encode. And just as before, instead of transmission, which is what we had before, we're going to do it based on weight. Okay, so we're going to say that the x-axis will be encoding weight. And I will go with the default, which is quantitative, so I won't override it, and I'll say bin equals true. Okay. Now remember, what a histogram is showing is the distribution. So we want to know how many cars, how many elements fit into each binned weight, each of the different weight bins. So y equals alt y. Again, we're going to use this count thing, and that should be it. And now we see the distribution. We can see based on the weight binned, this is times 1,000, I think, you can see how many records sort of fit into each bin. There are other kinds of things that you can do to override the binning. So if you don't like the particular way that Altair or Vega Lite decided on how to bin, there's something called bin parameters, which we can use to override this. And so an example of this, let's say I don't like the way this is displaying. I don't think this is fine-grained enough. I actually want like 20 different bins. So I'm going to copy this code. I'm going to go over here, and instead of bin equals true, I'm going to give it additional details. So I'm going to say, hey, Altair, use this bin parameters object and use the max bins value of 20. And you can look at the documentation for bin params. There's other parameters that you can set, but this is basically just saying, instead of just go with the default binning, I'm going to give you a configuration for binning using this bin params object, and it's going to specifically indicate that you should use 20 different bins. And so you can see it like this. Okay, so now you get a much finer resolution version of the histogram. Okay, let's see if we can do an additional little bit of sophistication, which is adding sorting into the mix. So we want to actually have a nicer display of the data on the screen. So let's go over here and try to sort. So before, what we had, we used to have this visualization. So let's recreate it, mark bar, encode. I'm going to use that model number visualization, or the model name visualization. So along the x-axis, we're going to put miles per gallon. Along the y-axis, I'm going to encode the model. And so this is the unsorted version. This is whatever order. Let's keep this consistent. So again, you can mix the different kinds of ways you describe the encoding, but just to be consistent, I'm going to use this so it all looks the same. And we get a visualization that looks like this. This is, again, based on the order that the data set is in, which is just alphabetical order in this case. This is how we loaded it. This is not what we want. What we would like to do is have the visualization render so that, based on the y-axis, So the models along the y-axis are ordered based on the length of the bar. So more miles per gallon, the longer they should be. So the way we do that is we can add this extra little bit to the encoding variable. And let me just move this back, and we're just going to do it like this. So I'm going to say sort. So just like we had that bin thing before, now we're going to use sort. We're going to say, Altair, use this encoding sort field object, which is going to specify the rules by which I sort. The rules by which I sort, in this particular case, I want you to look at the miles per gallon field. Okay, so whatever the miles per gallon field should define the sort order for the model. Okay, and here I'm going to also say that I want the order to be descending. Okay, I could have it ascending or whatever, but in this case I want it descending. So now we plot this, and we get a nice visualization where the Toyota Corolla, which has the highest miles per gallon, is displayed at the top. So again, what we've done is we've added instructions about how to sort. The way we do that is we use a specific magical sort object that Altair knows about. It's called an encoding sort field, which tells it which field to look at when deciding how to sort. In this case, we've said use the miles per gallon as a way of determining where models should sit along the y-axis. So instead of going with the default sort order, which is just whatever was in the data frame, happened to be alphabetical, it will actually try and do something more sophisticated and sort based on this value, the miles per gallon value, and again, in descending order. Ascending should be the other way. Okay? Okay, so there are many other kinds of marks built into Altair and Vega Lite. I'll encourage you to go play with them and go look at the documentation, but I just want to give you one very quick example on how you can use the mark approach to build somewhat sophisticated visualization. So one specific example might be a heat map. So if you've seen them, basically it's a bunch of rectangles that are going to be color-coded based on how many things are in each bucket along the x and the y axis. So hopefully you can visualize that in your head, but if not, you'll see it in a second. So in this particular case, I want to look at cars based on the miles per gallon and the horsepower, and I want to know how many different cars of that combination exist. So we're going to bin by both properties, miles per gallon and horsepower, and we're going to look at the count in there. So, hey, Altair, make me a chart using empty cars. In this case, we're going to use a rectangle encoding as the mark. I'm going on to put on the x-axis the miles per gallon, and I want to bin those. Oops. And along the y-axis, I am going to put horsepower and bin those. By the way, it doesn't actually matter if you use single quotes or double quotes. I'm just trying to keep things consistent. So color equals count. Okay, so this says bin on these two dimensions and plot the two dimensions, the miles per gallon on the x, the horsepower on the y, and the color of the rectangle should be set to the count. And voila, we have a nice visualization that is showing us a heat map telling us how many records of each type. And so you can see this dark blue over here. Let's get the highlighter. This dark blue over here, and that is where there's a lot of cars of that specific value. And then there's no cars over here and few cars over here. All right. So as I said before, I encourage you to go play with the different kinds of marks that you can use and look at the examples on the Altair website. As we go through these different labs, you will see many more examples, but you can start playing with them already. Let me show you just a few more quick things just to give you a taste of what you can do with Altair. The first is building compound charts. So sometimes one chart will not be sufficient for our needs. So we're going to want to put two charts side by side, and this is what's called a compound chart. So let's say we have two different data sets, or sorry, we have the same data set, again, the cars data set, but we have three different variables that we want to show. And we want to do that so that we have two scatter plots sitting side by side, or two bar charts. Let's do it in this case. One should have miles per gallon versus model, and the other should have horsepower versus model. And so what we can do is we're going to create a Altair chart, and we're going to name it models miles per gallon. So let's start like this, actually. So we have hey, Altair, make me a chart. Make it using the cars data set. Make it a bar chart. Encode On the x-axis, please put the miles per gallon. On the y-axis, please put the model number. Okay. So if we display it, we've seen this visualization before. I'm going to save this visualization. So instead of rendering it to the screen, I'm going to save it into a variable called model miles per gallon. Okay, so that's going to be a chart. So if we run this now, it won't display. Model MPG is holding the value of that visualization. So if we actually run it like this, you'll see the visualization. Okay, let's make another visualization. In this case, we're going to change this. We're going to copy, and we're going to make, instead of miles per gallon, we're going to use horsepower. Okay, and we're going to use on the x-axis, instead of miles per gallon, we're going to use horsepower. And so just so you can see what it looks like, I'll plot it. So this used to be miles per gallon on the as the length of the bar, and now it's horsepower. Okay. So how do we get these two charts to sit side by side? The awesome thing about Altair is there's a very simple way of doing that. So you say, hey, plot the model versus miles per gallon, and right next to it, do the model versus horsepower. This little pipe, okay, is actually saying put something side by side, okay? Model MPG versus model horsepower, and we display it, and voila, we have the two visualizations side by side. The other way of doing it, which is more explicit, is using this Altair hconcat horizontal concatenation, and it takes two arguments, the model versus miles per gallon and the model versus horsepower. Okay, and that's a very easy way of getting the displays to sit, the two visualizations that we've created to sit side by side, and they're actually at the end part of one visualization. So you can see that there's only one little three-dot little icon that you can look at. All right, so this is how you get them to be side by side. Let's go to the next one really fast. If I want it to be one on top of the other, instead of the little pipe, I would use the ampersand. If I run this now, you won't actually be able to see it because it stretches off the display, but you're just going to have to believe me, and you'll see it in your own notebook. If you roll down below this, actually, I can just exit out of this. You'll be able to see, okay, one visualization is sitting on top of the other. All right. So that's how we get vertical concatenation. The other way of doing it is using this command, Alt V concat, vertical concatenation, put model miles per gallon next to model's horsepower. And you can do any kind of combination of this. So you can have mixes of things like, something like this. So now you get the model's horsepower and model miles per gallon sitting next to each other, and then another copy of the other ones sitting on top. So let's exit so you can see this. Okay, so now we have the two visualizations down at the bottom because that's what we've asked for, and the one visualization up on top. Let's just get out of this. Run this again, and this is the clean version. The one thing that I will caution you about is there are occasions when, because of the way you've created the visualizations, the axes will become misaligned. So the y-axis in one will be a different value than the other. And so there is a way of forcing these things to sit next to each other. So we're going to make model MPG versus model H horsepower next to each other. And then we're going to use this special command called resolve scale. And in this case, we want to tell it that the y-axis should be shared. Now in this case, it's not actually going to do anything different. It'll look the same to you on the screen when I run this as what we've seen before. But if you ever run into this problem where one visualization becomes misoriented relative to the other when they're sitting side by side, you can force Altair and Vega Lite to use shared axes using this command. Okay, so we have a nice visualization like this. Okay, for the very last thing that I'm going to do, I'm going to show you how you might style your visualization so you can get them to look the way you want. And there are two options for doing this. The first I'll call the DIY option, do-it-yourself option, and the next I'll show you how some of the built-in themes can be used. So let's take our visualization that we created before, which is the model versus miles per gallon and the model versus horsepower, the side-by-side version. And let's say I don't love the sort order right now. I want to actually have it be based on reverse alphabetical order. So let's do that for both of these things. So we're going to say sort alt encoding sort field, and we're going to sort based on the model name. So field equals model and order equals descending. Okay, so let's make it like this. And then I'm going to do the same thing for both charts. So let me just copy this over. So now we've created a sort field, which is this alt encoding sort field. It's going to use the model variable. Okay, and then going to sort along the y-axis in descending order, so in reverse alphabetical order. So if I plot this, you'll see that the Volvo is now on top, then the Valiant, and so on. So the cars that are A's are sitting at the bottom. Now, I still don't like the look and feel of this, and so as I showed before, where you can fill in the dots, you can do the same thing to change other aspects of the visualization. Like you can make the visualization on the right, like I think the bars are too thick, so I can make the height of the bars equal to 5, so make them a little bit thinner. And I can go over here, and I don't like that they're using the same color because it's two different data sets, so I'm going to make the thing on the right pink. Okay, so using just this very simple command, we can modify the look and feel, and we can mix these things up too. So let's say I go back here and make this green. Now I have a green thin bar chart on the left and a thick pink bar chart on the right. All right. So that's kind of the basics of getting your own visualizations to look the way you want. So let's go over here. We're going to go back. We're going to plot it again. Now, you can do other things. So let's make sure that the scale, the y-axes will be the same. So they are the same because we've sorted them, so we know this will work. But just in case, we're going to force it to the shared configuration. And when you do this, this entire thing is actually one visualization. As I've said before, you can see that there's only the single 3-dot little button over here. So you can go back and say dot properties. And over here, you can modify the properties of this shared single visualization. So let's give this thing a title. So title equals miles per gallon and horsepower. And now at the top, you'll see one title being displayed for the two visualizations. All right, so I basically said, create one single visualization that includes these two sub-visualizations and add a property, in this case, the title, which is MPG and horsepower, and put it at the top. As I said, there is an alternative for getting visualizations to look the way you want. And if you have very complex kind of theming, this is something you could use. And there's a bunch of built-in themes into Altair that will make visualizations that look like specific kinds of newspapers or websites or whatever. But you can also create these on your own using a little bit of like HTML, CSS flavoring. So let's copy a visualization that we built before. Very early on, this one. So if you remember, this is sort of the default look and feel of Altair. And let's say I don't like this. What I want to do is use the 538 theme. So Altair has a bunch of different themes available to it. And this is a built-in one using the 538 website as inspiration. So I say, hey, Altair, enable your themes, specifically the 538 one, and you get a visualization using the right set of fonts, the right colors to make it look like the 538 website. Okay, so when you do this, this particular thing here, 538, is now enabled for all subsequent visualizations. If you don't like this and you want to go back to the default, let's go to the next slide, you can replace 538 with default, and now all visualizations that you plot after this will have the default theming again. Okay, just as a summary, Altair is a really powerful way to produce Vega Lite. If you know Python, this is a great way of doing it. You should always, when you're doing this, be thinking in the same way you would have thought if you were using any other kind of grammar of graphics. You should think about the marks that you want to use. So what shape do I want and what do I want the shapes to represent? Data, which variables do I care about? Encodings, how do I want to map them onto the screen? As you'll see, you can often pre-process the data in pandas, but there are powerful built-in functions like the count and so on, and we will see many more examples later on. Now, if you're stuck, I'm going to encourage you to look at the documentation for Altair, Vega Lite, and sometimes Vega. Those are available on the web for you to play with and will be very useful for you.